Ahoo! I'm here at Big Elk Park on the Omaha Res today, and we're getting ready to do a expedition for the Facebook group Res Squatching. So we're just getting started. We're going to have dinner here shortly, but I wanted to visit a little bit about some of the evidence over the years that I have presented. I recently had gotten some feedback from some family members that it would be good if I tried to simplify the MUC7E that I had proposed, the theory on how that relates to all of the world's hominids. So I'm going to try to simplify that today. Essentially, when you do DNA, when you spit into the little tube that you're given, that mucus has a protein in it that's called MUC7, and that protein is unique to all Homo sapiens, including hominids, Neanderthal, and Denisovian. Within that protein, MUC7, it has a sticky consistency, and that allows it to fight bacteria. So that's the purpose of it. When study was done in 2017 regarding this protein MUC7, there was a population identified in sub-Saharan Africa, and there hadn't been a whole lot of DNA studies done in Africa. So that was why this was done. They did isolate this MUC7E and find that it was an outlier, and it existed within sub-Saharan Africa, similar to what Neanderthal did with Europeans. There was an introgression, which means there was a mating that occurred in ancient times, historical times, that occurred maybe 1,000, 10,000 years ago. And in that, there was this Neanderthal DNA in Europeans, Denisovian, and like the Sherpas of Himalaya. We're seeing that in Asian populations, also the Denisovian. So this is unique, and in sub-Saharan Africa, that this population had a introgression into their DNA, and their MUC7, which was different. It was wildly different than the MUC7 that is within Homo sapien, and Neanderthal and Denisovian. So this is what I found very interesting when I read this study, and I wound up tying it to Zana in Russia. And Zana was a captive hominid that had been clubbed, and she was very young, and she was caught in the Georgia region of Russia, and she was taken passed along to various noblemen, and she wound up with Geneva, a nobleman who took her in and wound up through procreating with her and having offspring, several of the men in the village that he lived. The DNA from Zana then was carried on to her descendants, and that DNA held sub-Saharan Africa DNA when that was studied in 2013 by Dr. Sykes. So that's what led me to sub-Saharan Africa, and led me to the study eventually that came up with this MUC7E protein. Now, I have taken that MUC7E and expanded on it as an emergent homid theory, explaining that this was a unique hominid, an archaic hominid out of Africa, out of sub-Saharan Africa, and that it had interbred with other hominids, such as the Denisovian, the Yeren, or the Denisovian, the Neanderthal, and Homo sapiens. And in those populations, we now have the Yeti, which would have been a interbreeding between the Denisovian and this archaic MUC7E progenitor. So we're seeing a consistent DNA history of when this intergressions were taking place. What is interesting to me is here in modern times now, through Zana's DNA, we can show that there was a modern introduction of this archaic DNA from sub-Saharan Africa. We're trying to identify it today in having additional environmental DNA studies and going back and studying people that carry that MUC7E. I think that's what you're going to see. You'll see an algorithm developed from this, and we'll be able to see environmental DNA studies, which is where they'll be able to pull it out of the water, because it is this sticky consistency that is in all of our mucus. This will be unique because it's an outlier. The MUC7E will be something that we could have like a blue colored marker, and that would be able to identify that if we took it out of environmental DNA, such as the Mississippi River or the Missouri River behind me, the different creeks that flow through habitat where these hominids live. That would be shed in that water, and it would also be in if they had been eating or their tree and stick structures. It could also be a part of the sticky substance that is sometimes found in residue with their fingerprints. That may also carry remnant DNA, and that DNA might point also theoretically to MUC7E. I believe this is the genetic marker, and this is what's going to be used in the future to study these hominids in places such as the Omaha Res, where I'm at today. So I hope I simplified it a little bit more when it comes to our own DNA and how people do have this mucus system, and within that it carries all of our DNA. And within that DNA, there was an outlier found in sub-Saharan Africans. And within that, we have identified MUC7E, and we're able to trace it to sub-Saharan African DNA to Zana. So more studies will need to be done, but I believe this is absolutely the genetic marker that will be used in the future, and it also proves their existence of these archaic hominids today throughout the world. So this one progenitor out of sub-Saharan Africa DNA would be in the MUC7E, would be in the Yeti, the Yeren of China, the Yowie of Australia, and the Sasquatch of the U.S. Other hominids around the world will carry that DNA, and that will be the marker from this distinct individual archaic homin that carries the MUC7E. This is Richard Soule in the land of the giants, res squatching and the Gigas study.